Hello, everybody. Welcome back to Algebra 2. We are going to start Unit 4 today. And really, the first half of this Unit 4 is about exponential growth and decay. This is something you've talked about in previous math courses before. We're going to go more in depth into exponential growth and decay. And right here on your screen are basically your lesson notes for the entire first half of this unit. Your basic exponential growth and decay formula is here. So if you remember, to create an exponential growth or decay formula, you need an initial or starting value, and you need a growth or decay factor. If it's an exponential growth situation, then your growth factor is greater than 1. If it's an exponential decay situation, then your growth factor is less than 1. One of the things that'll happen very often is that your growth or decay factor will involve a percentage, meaning you're increasing by a percentage each time or decreasing by a percentage each time. In cases like that, when you're increasing or decreasing by a percentage each time, this is how we figure out the growth or decay factor. So for example, if you're increasing by 2% each time, for example, we know that 2% is 0.02 as a decimal. So the growth factor would be 1 plus 0.02 or 1.02. If we were decreasing by 2% each time, then my decay factor would be 1 minus 0.02 or 0.98. So that's how we figure out our growth or decay factors. With that in mind, let's take a look at the examples for this lesson. So here we're going to talk about a problem involving a U.S. passport photo. So the distance from Elena's chin to the top of her head is 150 millimeters in an image. For a U.S. passport photo, this measurement needs to be between 25 and 35 millimeters. Find the height of the image after it has been scaled by 80%. The following number of times. Explain or show your reasoning. So to help us with this, okay, scaling by 80% means the height is going down by 20%. So scaling by 80% means the height is going down by 20% each time. That's going to be the key in this case. So when I plug in to my exponential growth and decay formula, we need to know that. So what is my initial value going to be here? My initial value is going to be the 150 millimeters. So that's the initial value. And then for the B value, all right, the key again is we're going down by 20%. So 20% as a decimal is equal to 0.2. And because we're going down, my decay factor is going to be 1 minus 0.2, which is equal to 0.8. So my decay factor, my B value, is going to be 0.8. Okay, so if I were scaling by, for example, 60%, that would mean I'm going down by 40% each time, and I do the same thing I did here. But in this case, we're scaling by 80%, which means we're going down by 20%. How did I get that? 80 plus 20 is 100. So now let's actually find the answers to number 1. So find the height of the image after it has been scaled by 80% the following number of times. 3 times. So this is going to be 150 times 0.8. And if we're scaling it 3 times, it's going to be 0.8 to the power of 3. And for B, okay, if we're scaling it 6 times, it's going to be 150 times 0.8 to the power of 6. All right, so what I'm going to do is I'm just going to go to Desmos, and I'm going to calculate this. So we have 150 times 0.8 to the power of 3, and we have 150 times 0.8 to the power of 6. So 76.8 and 39.3 are my answers. So 76.8 millimeters and 39.3 millimeters are my answers to number 1. Okay. Number 2, how many times would the image need to be scaled by 80% for the image to be less than 35 millimeters? Okay. So what, in other words, what would my exponent have to be in order for the answer to be less than 35? So to do that, I'm going to go back to Desmos. Okay. If we do it 6 times, we're still above 35. So we know it's got to be at least 7 times. So let's see what happens if I make that exponent 7. Okay. And what do you know? It's 7 times. We're now less than 35. So to get the image to be less than 35, all right, I would have to scale the image by 80% at least 7 times. At least 7 times. Because at 6 times, it's above 35, and then we saw at 7 times, it's below 35. Okay? So number 3, we're going to do the same thing, except how many times would the image need to be scaled by 80% to be less than 25? So to be less than 25. So let's make this an 8. Okay, that is still above 25. So it's probably going to be 9. All right, now it's below 25. So to answer that question, how many times would I need to do that? Because the exponent is 9, it would be at least, it would have to be at least 9 times. Okay? And I just did that by playing around with the exponent on Desmos until I got an answer that was less than 25. Okay? And that is it for this lesson.